Hey, it's Jelani. Today I wanted to do an episode of Patch Notes focusing on a concept that I heard on a podcast called Source of Uncertainty called gate trains. Essentially, instead of using the sequencer for the gates to have specific notes that you choose and they play, you use a continuous stream of, essentially gates that you then kind of filter out. That way you can control the density of the notes going into the speakers. Let me kind of show what I'm talking about. So I'll start with just the sound that we're working with today. It's a combination of the two harmonic oscillators and the complex oscillator going into the scan and pan. I'm just using a random voltage to move the filter around. So this right now, that's the sound we're going to be working with. The whole concept, essentially, I'm going to get the voltage multi-stage as gate output, and I'll use the control voltage processor pretty much for everything. So you can do this whole thing with just these two modules. So I'll take the gate output from here, and I'll take that into the input. Essentially, on the CV processor, you have different sections. For the middle and bottom section, they're both identical. Essentially, you have a crossfader that will go from input 3 to input 4. And with CV, you can essentially control how much of input 4 you're receiving if it's facing input 3 with a positive voltage. So if I'm starting it up now, we have all the gates from the voltage multi-stage 16 going into the CV processor, and only when it opens up do you see the output blinking, showing that gates are essentially going through it. So I'll take the output from here to my envelope generator. So let's take one of these guys, patch it over here, and you're here. When I turn this knob, I'm allowing the gates to essentially flow through it. Now for the envelope that I'm going to use to essentially open it up, I'll use the top part of the CV processor. So I'll get a cable from the trigger to the gate output. Now essentially we have an LFO happening. So if I grab another cable from the output from this and I take it into the select input, now essentially we're using the envelope to allow the notes to go through. So essentially I'm opening the door for the gate train to fly through. Now we can control that envelope with the rise and fall, and you can kind of make more interesting patterns that way if you, let's say, reference it to a kick. So, and you can kind of essentially like improvise, freestyle, how that goes. And now instead of like trying to select the individual notes, you're just working in densities. Another cool way of thinking about this, instead of the gate train, you can call it like subtractive sequencing instead of synthesis. Because essentially you're starting with just a continuous notes and then you're subtracting what you have there. Because this envelope isn't tied to the clock, it phases in and out kind of. And why that's also useful for the Verbos modules at least, if you're turning the gates on and off, you're also turning off that row of modulation or that step of modulation. So now you can have all the essentially 16 steps or 8 steps or 10 steps with the CV controlling something. So right now I have that routed to pitch for all of them. Not, the gates are still continuous, so you can still have pitch going across all of them. Or whatever you want to use that CV for. then if you ever want to just like go back to the 16th note, you can just turn. And then back to the gate train. So yeah, gate trains are subtractive sequencing. Yeah, patch notes. And one more thing that I just realized that I want to kind of mention too, you don't need the voltage multistage 16 at all for this. In fact, if I take it out of here, I can just have the gate train itself coming from whatever clock I want. So in theory, I could do this entire thing with just the CV processor. So So you could just use this itself as its own sequencer in a way. Yeah.